Hello and welcome to Chandara Academy. Today we're going to solve the third exercise of the 2021 exam about complex numbers. So, first question. Given a complex number z1 is equal to square root of 2 plus I square root of 2, find its conjugate, named z1 conjugate. So, let's remember what is a conjugate. So, written in algebraic form, a complex number can always be written as z is equal to a plus ib, with a and b integers. So, what's its conjugate? Its conjugate, z conjugate is equal to a minus ib. If it's written in polar form, okay, so z is equal to r times e to the I theta power, with theta r integers. Okay, its conjugate will be z conjugate is equal to r exponential of minus I theta. So knowing that, we just have to replace this plus by a minus to find our solution. So z1 conjugate is equal to square root of 2 minus I square root of 2. Easy one, right? So let's place it on the complex plan to understand a little bit more. So let's write the plan. So A here, B here. So we go square root of 2 to the right and square root of 2 to the top. Square root of 2, square root of 2. And this is the number, so the point associated with our number, square root of 2 plus I square root of 2. So z, regular z. So let's try to find the module. R is equal to mod of z1 and the angle theta, okay? So how will we find it? So to answer the second question. Okay, so the modulus B, so the modulus mod of z1 is equal to, we can find it using the Pythagorean theorem on this plan. So let's use it with this side and this side because we want to find the hypotenuse. So mod of z is equal r, let's name it, is equal to square root of the real part of z squared plus the imaginary part of z squared. So z1 is equal to square root of 2 squared plus square root of 2 squared, everything squared. Everything to the square root is equal to square root of 2 plus 2 is equal to 2. So easy one. Now let's find theta is equal the argument, that's called argument of z1, is equal to the arc tangent of the imaginary part of z1 over the real part of z1, as if we were talking about geometry. Okay, so is equal to arctan of square root of 2 over square root of 2 is equal to arctan of 1. So two solutions possible. The solutions will be pi over 4, so pi over 4 here, or minus or 5 pi over 4. So it will be there. But how do we choose it? How do we choose which one is the right one? Just looking at the sketch, just looking at where the point is. Okay, so the point is on the right top right hemisphere. So this is in this part. So the answer is pi over 4. Okay, so the answer would be either 5 pi over 4, either pi over 4. Okay, but we know it's this answer because the real part of Z1 is superior or equal to 0. So we are in this side of the plane. Okay, so just to understand because we've got a plus here. So this side, that will help you to find the right answer. So we just answered the question, and we want to write our number in trigonometric form. That's what I called the polar form. So trigonometric form of Z1 is equal to R exponential of I theta is equal to 2 times exponential of I pi over 4. And we answered the question. So now, last question. We want to prove that Z1 conjugate is the solution of this equation. Okay? So the root is the solution. So Z squared, we are just going to write the equation. So E, okay, Z squared minus square root of 2Z plus 2, okay, so is equal to 0. So I switched this number on this side because they were here, so one negative sign appeared. So now we want to know if Z1 is a solution. Okay, how do we know if Z1 conjugate is a solution? We're just going to inject it. So inject Z1 conjugate into the equation. Okay, so replacing Z by Z1 conjugate. Let's do it. So square root of 2 minus I square root of 2 squared minus square root of 2 times square root of 2 minus I square root of 2 squared plus 2 is equal to 2 minus I square root of 2 squared, so 2, okay, 2 plus I squared square root of 2 squared, so minus 2 minus 2 plus I, let's remember the equation. There is no square here, so plus I square root of 2 times square root of 2, so 2 plus 2, and it's equal to this one simplified with this one simplifies with this one, and this one simplifies with this one, so everything is equal to 0. So this one conjugate is a solution of E. And we answered the whole question. Okay, so hope you enjoyed the video. I'll see you the next time. Bye.